That's why they've developed a set of formulas that they use to try to get an idea of what's happening when it moves into an environment. These are the concentration ratios that you see. Let's explain it this way. First line, concentration ratios are used in most radiological models to predict whole body radioactive or radionuclide activity concentrations. They use these for wildlife. Different factors for different animals changes these. So they're using math and statistical analysis to justify what is being distributed into the field. Now we will move on to a spreadsheet that I've transferred these numbers here. This is TEPCO's spreadsheet. And I'll show you the group that I used, which is the J1-C group numbers. And you'll notice over here on this right side where the notes are, you'll see things like in radioactive equilibrium with cerium-144. That just means that the daughter of the parent is decaying at the same rate as the parent is decaying to that daughter. Understand? And you'll see things such as assessed using the radiation concentration of europium-154. These are the energies that they are assuming that occur because of something else occurring. Okay? Continue to show the rest of them so it is on record what the numbers are. And it can be checked that these are the correct numbers and transferred over. So these are the numbers that I used for my spreadsheet. Okay. And up at the top, you'll notice that what I used was the becquerels per liter from the first and the second treatment. And the only added factor here, the only added column is what's in red, which is the amount per tank. So that would be becquerels per 1.23 million liters, which is what one tank holds. As you follow the red column down, you'll notice there are some issues. There are some things that aren't put in that should be put in. That either the person plugging in these numbers didn't calculate right or didn't put in ND, which is non-detectable because we'll go down and show the legend. Okay. A black asterisk means levels shown below detectable limit of detector. That means that their detectors cannot see the amounts and levels below a certain point. The colored in columns are levels above 1 million becquerels in each tank. That means the total in each tank is above 1 million becquerels for that specific one. And the red ones with the asterisks are the levels that are below or are either at or below the total because they can't see below that amount. So they're either at or below. And as I explained, this is why this has to happen, because estimates and approximations are being used when perfection is required. Okay, now I'll go down and show slowly these numbers. So if they want to be challenged, they can. The half-lives are all the way to the right, where they should be, next to where the becquerels are. And we'll get down to the bottom and see the total, what the total is in one tank. This is very on the fly. I have some notes prepared, but it's turned into something on the fly here. Now you'll see it down at the bottom is the total becquerels per one tank. That reads 271,945,435.51 becquerels per tank. Knowing that there's roughly 250 tanks that have the second treatment of the ALPS, you times that number by 250, and what you are left with is 67 billion with a B, 986 million with an M, 358,877.5 becquerels in those 250 tanks out of the 1,000 at the site. Surely no one in the world really thinks this is acceptable to release into the ocean, especially knowing the way they attempt to justify it through concentration and ratios. Shame on them, and shame on us if we don't make certain that that water isn't dumped. The only reason they want to dump it so quickly is so that a daughter doesn't decay into another daughter and bring up the levels above safety standards. Then they would have to do the entire process of running it through the ALPS system again and build an entire new tank to hold that water, and would be a fourth tank in that series of 3 that lead us to these numbers that we are now. That is what it's about. Nothing more. Thanks for joining me. Like, thumbs up, comment below, and check the description box for links. Thanks, guys.